And I started doing my first test case. The test case was very simple. Test a file with open type font. Okay? Naturally, if it is Adobe Reader, it has to be a PDF file to test with open type font. How much time do you think this is going to take to test? You are as new to it as I was back then. So give me your estimate. How much time to test this test case, simple test case, open a file with open type font? Don't worry what is open type font. It's just one of the fonts. Sorry?
3 weeks.
3 weeks. Anybody else? Anybody else? How much time? Take a guess. Any number is good.
Current number is better.
Sorry?
Let's take it from another side,
30 minutes. Okay. So 3 weeks, 30 minutes. All right. Anybody else? Of course, this is the first round. In the second round, I'm going to ask you to justify your reasoning. Right? Yeah, go ahead. 2 weeks. 2 weeks to test just one test case. Open a file with open type font.
It's less than 3 weeks, so.
All right. Yeah, this is just one test case in the sense that open a file with open type font. That's the test case. 3 days. Anybody else? 1 day. If you were a manager and somebody told you you're going to take 1 day to execute just one test case, when I started testing it, 3 days I kept testing it. The end was nowhere in sight. I could just go on doing more and more and more. And then I realized that while I knew it all the time, but then I realized that testing really has no end. And you can keep doing it and keep doing it, keep doing it, always doing new things for 3 weeks. After 3 weeks, what happens? That's a mystery. We'll try to solve it. So the question was, how many of you are ISTQB foundation level certified? Okay. How many of you know what are the various test design techniques? Name them, please. One per person. Okay. Yeah. Anybody else? Pairwise testing. Boundary values, pairwise. Anything else? Equivalence partitioning.
Decision tables, state transitions,
Anything else?
linguistic analysis.
Linguistic analysis. So the question that I have for you is, how many of these techniques do you think you would be able to apply on open a file with open type font problem? And how many test cases would you be able to produce in order to enable you to test for not 1 day, not 2 days, not 3 days, but 3 weeks? So this was a problem I had. For 2 years, we were testing one version of the product. So one version of Adobe Reader to come out took 2 years. There were 100 plus testers. So 2 into 100, 200 person years of testing effort. You have to do really deep testing. How many test cases can you really write? And we found that as we test, as we do exploratory testing, more and more test ideas come to our mind. I believe all of you do exploratory testing as well. So now my challenge was, how do I take the thought process that's in the tester's mind during exploratory testing and convert it into a technique using which I can do large number of test cases in a more uniform way so that the technique can be applied by everybody and everybody would come up with some basic set of test cases, large number, but everybody would be able to come up with some basic set of test cases. So this was a problem I was struggling with. I always liked going back to the theory, understand how bugs get put into the code, understand how tests get written, how human brain or human mind thinks, and how can I convert it into a technique. So outcome was linguistic analysis, and this technique I started using sometime in 99, 2000, and then I used it in Adobe on Adobe Reader, and then I started a testing services company. I had some 300 testers at one point of time. We used it for a lot of our clients, and then I sold the company, so I no longer run that company. We found this to be a very interesting technique, and it developed over different phases. So I will try to tell you about what this technique is, how you can use it, and today, what is the relevance of this technique? Okay? What's the question that I'm going to ask you? Relevance of this technique today in the world of Agile and DevOps, where you don't really want to write too many test cases. The whole boundary value analysis, equivalence partitioning, is all about all pairs, is all about reducing the number of test cases. And here I'm saying, I want you to write millions and millions of test cases. Well, not write, but think of millions of test cases. So I'm going counterintuitive. I'm doing what other people tell you not to do. Do you think that's a wise thing? Do you think that's a good thing? Instead of trying to reduce the number of tests, trying to do large number of tests, is that good or bad? Sounds promising. Yeah, all right. I thought some of you are going to say, but that is stupid. Yeah, that's me. So let's take a look. Let me try to. So before we go there, let me ask you a question. How many of you have taught how to write test cases to fresh testers, young testers who've just joined, they don't know anything about testing? You have taught them? Yeah? Excellent. How do you teach them? Now that's a tough one. Yeah? So how do I find out that this is stupid or this is bullshit?
Does it work? Yeah. So my approach is first to look some test design techniques before start anything. The other is look for heuristics.
No, you are teaching me.
Yeah.
No, you're not doing test design yourself.
No, yeah, I'm teaching you.
Yeah.
So I'm teaching the people first of these testing techniques and heuristics.
Okay.
So after that, looking for the best way for the.
You
the
have
best
already proceeded much ahead. Let me bring you back. How do you teach me? So teaching a test design technique is simple, right? Boundary value analysis and so on. How do you teach? How do you know that there is a boundary here? Typically, you use examples, right? We teach by examples. We say, okay, login dialog, apply boundary values, minimum number of characters, maximum number of characters, and so on, right? And the person learns not from a method, but from example. That's how we do, right? All of us learn from examples. When you were a kid, you were growing up, how did you learn your native language, your mother tongue? Nobody taught you grammar, right? Nobody taught you rules. What did they teach you? They would correct you. You would try to imitate, and if you did something wrong, you would be corrected. And automatically rules formed here, and you began to understand how to form sentences and so on, correct? Now if I ask you, can you give me a technique in writing test cases based on requirements? And not all requirements have boundary values and equivalence partitions. How would you write it? So it becomes a very difficult question. And the only thing then again people revert to is teaching by examples. Now, take a look at this sentence, this slide here. How many of you are aware of object-oriented design? You must have heard the name even if you have not done it. There was a time when object orientation was not in vogue. It was not popular. People were struggling with OO, and structured programming used to be done. C++, Java wasn't even there at that point of time. C++ had come in, a few other languages. And then somebody said, how do I identify the classes and the objects? This is a problem in object orientation, right? When I'm doing design, where do I get my classes from? What are the methods that should be associated with the classes? So somebody said, well, look at your requirement, find the noun. The noun is the class. All the verbs that can act on it, they are the functions or methods. Let's take a look. You know what's in ATM? Or is it named differently here? Bankomat, yes. Accept deposit. Now I have to write a test case on accept deposit. What do I do? So if it's a test case, I say deposit needs to be tested. That's the noun. My system should accept deposits. So that accept is the verb. And now I know that deposits need to be tested. So how do I know? I identified the nouns. Nouns are the things to be tested. The verbs that can act on that noun are the actions to be taken. So writing test cases or teaching how to write test cases is very simple. You tell people, read the requirement, extract the noun, look at all the verbs that can act on that, and you got your test case. Elizabeth Hendrickson, she created this technique called noun and verb technique. And of course, you can then have adjectives and adverbs as well. For example, you can say accept deposit. What kind of deposit? There are a lot of different types of deposits. Every type of deposit forms one more test case. So it's an adjective. Similarly, how is the acceptance or withdrawal happening? Fast, secure, these are adverbs. So if you identify adjectives and adverbs, you get more test cases. So all you have to do is read the requirements, look at the nouns, look at the adjectives, look at the verbs, look at the adverbs, you got your test cases. Now we can all go out of this room because presentation is over.
Thank you, sir.
Pleasure.
Heard of t-shirt.
What do you think are problems in this approach? How many of you are agile? What kind of requirements do you have? None. Okay, the developers say we are agile, we don't do documentation, right? User stories? Yeah, some. How many sentences? Let's say 10 sentences. How many nouns can you really find out from those 10 sentences? So the technique can only work if you have sentences from which you can extract the nouns, correct? If you do not have sentences, you have no nouns, consequently, technique cannot be applied. So that's the problem with this noun and verb technique. Requirements are not sufficiently detailed, so you cannot extract enough nouns and verbs. Also, you cannot write complex scenario-based test cases. If you see, these are simple test cases. Whereas many of you are system testers, you have to test from end-to-end flow. So how do you write those test cases using this technique? So this was the challenge. And interestingly, my analysis of requirements used to happen on the basis of grammar, although I didn't have words for it. And one day I attended this session from Rex Black where he talked about this technique, and suddenly I found out that what I am doing can be called as noun and verb technique. But as I was not happy with the current form of the noun and verb technique, I extended it and performed a better linguistic analysis to create this technique. Now I'm going to teach you how to use this technique. Very simple method. Extract the nouns and the verbs, use 5W1H and pre and post conditions to extract more noun and verb, enumerate properties, break down the properties to base elements, use boundary values, equivalence partitions, write test cases, combine them, simple, done. All of you must have understood it. No? Okay, then let's take it slow, one by one. This is okay? What is 5W1H? What, why, where, when, who, how. Now, of course, you can add your own flavor, how many, how much, and so on and so forth. Sorry? It is? How? Yeah. Very nice, open-ended questions. I've made good use of them when I was doing my engineering. I would be on the last bench, sleeping with 1.5 eyes closed, and I trained my mind so that whatever teacher is saying, only the current sentence stayed in my mind, everything passed like this. So I had exactly one sentence buffer in my head. And of course the teacher would look at this student who is sleeping, so he would call me up, "Yes, Mr. Vipul." And I would immediately get up. You see, I had only 1.5 eyes closed. It takes some practice. So I would get up. This last sentence is in my head. I would apply immediately 5W1H to it. Whatever comes to my mind, what, why, where. "Sir, you said this. How does it really work? Or where do you get it from?" And so on. Sometimes the questions would be very stupid. Everybody would laugh at it. And sometimes the questions were simple but so deep, the teacher had no answer to those questions. So after a little while, the teacher stopped looking at me, and then I could sleep with both eyes closed. So this is the power of the technique. 5W1H, open questions. Let's look at these things later, but just read this one. Enumerate properties of every noun. What is meant by enumerate? List down properties of noun. So let's take a look at this. I have this requirement. The given application allows users to open supported files. Can you tell me where are the nouns here? Go ahead, please. Application, file, user. Okay. Verbs, open, allows. Okay. Adjective or adverb, supported. So an adjective. Good. We have done linguistic analysis to the extent of noun and verb. Which is the most important noun here and which is the most important verb on that noun? File, open, right? So file is the most important noun here. So we'll just take 2 words, file, open, and we will write millions of test cases with just these 2 words. Good idea, bad idea? Let's see. At the end of the session, I will ask you this question. But of course, given the fact that we talked about all noun and verb and writing a test case per noun, open file, 1, 2, 3, 10 test cases, that's about it. So let's see what we can do. So let me ask this question. What are the properties of this noun file? Can you give me the properties of file? What size? What is meant by type? What do you mean by type?
Document, the extension.
Okay, so type could, for example, type could be binary or ASCII, right? The type could be the creating application type, right? So extension, which you use on Windows as extension, so I'll just put the word extension. Anything else? Any other property? Name, size, access rights, date of creation. What else? Encryption, file system attributes. What else? Location. Okay, let's go to that. So file has a name, size, location, extension, the attributes that you said, metadata, state of the file. What does state really mean? Open or closed, okay. Anything else? Ever open, okay. Exists or not, okay. Corrupted or, okay, whatever, good. So, access control, password protection, attributes, compression, encryption, and so on and so forth. How much time did it take us to write this together? Maybe if we had spent 2 more minutes or 5 more minutes, we've got everything, correct? Isn't each one of these a test case? Sorry? More than one, but at the minimum, so you've got test cases in double digits. See, I have to take you to millions, by hook or by crook, because I made that statement, millions, so now I cannot go back on my words. Somehow I have to create millions of test cases. Otherwise, you're going to kill me. My application, only my application. Okay, so if that so happens, I will discard them. But like in brainstorming, you don't discard any idea at the beginning. Only once you start evaluating the ideas, you say this is applicable, this is not applicable. So we'll go to that. Tell me, what are the properties of a name? Yeah, so characters. A name has set of characters. So name is a string. String has a length. Length means total number of characters, right? Is anything else? So if I say name is a string, name is a sequence of characters, sequence has length, so name has a length, set of allowed characters, special or otherwise, whatever, and some characters that are not allowed. Is that good enough? Okay. How about applying boundary values now? So you said there's a length, so if there's a length, I can apply boundary values, maximum, minimum, allowed and not allowed characters, so equivalence classes. So I can apply now these boundary values in equivalence partitioning to come up with some more tests and so on. How about location? Location is also a string in one sense. If it is a string, everything related to string, all the test cases that you see here are applicable to location as well. So I can reuse these test cases for the location as well. It also denotes physical location, maybe on other operating systems, maybe on web page as a link, and so on. So there are various ways in which the location could be addressed. How about state? In use, not in use, saved or unsaved. If it is in use, then the file could be unmodified file, it could be a modified file, it could be a new file. If it's a new or modified file, it could be without data or with data. And if it is data, there are properties of data that you can look into. What kind of data does it have? Types, extension, with or without extension. If with extension, then with correct extension or incorrect extension. All of these are individual test cases. So from double digit, you are getting into higher double digit numbers to create test cases with just 2 words, file and open. Are you with me so far? Okay. Then there are attributes, read-only, writable, archive, hidden, whatever. Now, let's deal with verb. Let's stop with the noun. Too much of noun right now. I'm having digestion problems with so many nouns. So what we need is a verb. We need action, we need exercise. Apply 5W1H to the noun. Open what? What do I want to open? Each of these things is a test case. That's what I want to open. Right? So all files with various properties, supported and unsupported and so on. So I get double-digit number of test cases. Okay, where do you want to open? Here and now, on my OS, or it could be that I really want to open not in, let's say it's Microsoft Word. I don't want to open it in Word, the application, but as a plugin inside the browser. Which browser? So you start to get more test cases when you ask this question, just where? Yeah? How do you open? Oh, there are various ways to open. Double click, drag and drop, command line, application menu, right click and open with. Open how many? One, many, maximum numbers that can be opened simultaneously. How fast is it? And so on. So when you deal with Verb with 5W1H, you start to get more test cases. Okay. So if you look into these test cases and do a brute force multiplication, double digit numbers here, maybe single digit numbers here, we get hundreds of test cases. But still far away from millions of test cases, right? Let's see how we can get millions of tests. But before that, some simple positive test cases, minimum, maximum size, name length, where they are located, with or without extension, created using older, newer version of creating application, and so on and so forth. Each one of them a valid test case. Some negative test cases, unsupported file, changed extensions, corrupt file, non-existent name. So you can write a lot of positive and negative tests, which is good. But now let's get into that scenario where you can write not just hundreds, but maybe tens of thousands of test cases. Very simple. Combine the test cases. Open a file, open a file. Open a file is a test case. Open a file, open a file. That's also a test case. Sequence of actions. What is open a file? What is it that I want to open? So for example, I may say, I want to open a file which is new without data. Open a file, the next part. I want to open another file which is new without data. One test case. Open a file new without data. Open a file which exists and has data and is closed. Now you tell me, what would be the behavior of Microsoft Word if I have opened a file which is new, does not have data, and then I open another file which is already existing? What will happen? Microsoft Word, Excel, PowerPoint, any application. It'll have two files, okay? Do the same thing to Notepad, what will happen? If you do a file new on Notepad and then go and open another file, what will happen? Tell me. Well, it closes the new file which does not have any data and it opens the new file. Notepad behaves differently than Word. We didn't know this. We didn't care. We just used two test cases, two different scenarios, and it gave us a very interesting scenario that the developer may have implemented but forgotten to tell you. Maybe this is not how Notepad was supposed to behave. So then you say, okay, let me change the scenario. Open a file which is new but modified, not saved. Open a file, another file which is saved and closed. Now what should happen? Now you say, I was okay if it closed a new file which had nothing in it, but if I've written something, it should not close the file, it should actually ask me to save it. Correct? That test case comes automatically. Fine. How about open a file, open a file, open a file which is modified but not saved, open a file, open the same file again. Now there are two versions of the file, one which is modified, one which you are opening, Microsoft Word, what will it do? Notepad, what will it do? So these are interesting questions. My requirement didn't tell me anything. If my requirement made it clear, of course I don't need to write these many test cases, but I don't have requirements. These are the scenarios that are of interest to me. So this is a very clever test case. Open a file and modify it and open the same file again and see the behavior. Anything else? Can more such clever scenarios can be thought? By doing what? Nothing, just combining things, right? You look at these. And interestingly, in this, if I open a file in Notepad and use file open to open another file versus double clicking an existing file, will the behavior be different? So the question that we asked, how do you open, is not really a useless question. It's a very important question which tells you that if you use file open from within the file menu, the behavior would be different, but if you double click, the behavior would be different. It depends on how the developer has implemented the whole thing. You have no idea how the developer has implemented, so you want to throw as many scenarios as possible so you can find out those assumptions, you can find out those implementation details. Then things about opening multiple files together, checking the performance, open a very large file, check the performance, or maybe open a file, open a file, open a file, open a file n number of times. Do you think there's any advantage of doing this test case where you say open another one, or try opening the same file again and again and again, maybe 10,000 times? Do you think this test case makes sense? Do you think this makes sense? For him, yes, but for others? It doesn't? You can't support all this? Maybe what it does is just opens one file, opens it again. So there are no 1,000 files which are open, there's only one file open. But even there, if there's a memory leak in opening a file, you open it, you close the application, you don't even become aware of it, but you do it 10,000 times, and there's a 100-byte memory leak, suddenly you have 100 into 10,000 bytes of, so that's 1,000 kilobytes of memory leak, that's 1 megabyte of leak. You can notice that. So that's also an interesting test case. We need to understand how to use these test cases, whether they make sense in our scenario or not. So by combining these, 1,000 into 1,000 or thousands into thousands can give you hundreds of thousands of test cases, but we are still not millions. So I need to use some more trick to do millions of test cases. So therein comes the preconditions part. So if I take you to our steps, extract the nouns and verbs, use 5W1H and then use them to extract more adjectives, adverbs, and more information. Then comes this part of pre and post conditions. You've done the enumeration, now we'll use pre and post conditions to extract more nouns and verbs, and then their properties as well, and so on. So let's do that. Precondition. What's a precondition? Anybody will like to define what's a precondition? Yeah, go ahead.
Precondition is a state that should occur before you start the testing.
So precondition is, anybody else? Sorry? Okay, the context. All right. So precondition is nothing but the state of the system which should be before you can run a particular test case. Sorry, yes. Meaning, if you need data in the database before you can run a test case, that's the precondition. You need an application to be installed for you to be able to do something. That's a precondition. So there are a lot of different preconditions. How many of you have used, for example, installed Microsoft Word or Adobe Reader or Acrobat and then opened files, and at some point of time it would not allow you to open any file but throw up a dialog, please activate your software. Have you ever seen that kind of a dialog? Yeah? So when somebody wrote the user story, they said user should be able to open the file. Nobody really talked to me about this particular need. In preconditions, I'm asking, before a file can be opened, what conditions should be met so that file can be opened? File should exist. Application to open the file should be installed. Do I need activation of the software? So that gives me test cases. Do I need to check permissions? Is there some pre-processing that needs to be done? Now that's an interesting one. Any idea what pre-processing means? So when I launch the software for the first time, it might actually install some fonts, it might download some things, it might download certain plugins, and of course do activation and so on. So what kind of pre-processing might need to be done? So you ask these questions. Each of these questions may lead to more test cases. So preconditions are okay, but preconditions are more on the system side, so they're interesting, but not that interesting. What is more interesting is the post condition. What was my question? File, open. How do you know that file has opened up successfully, correctly? How do you know that this file has these many pages? It might actually be showing you only 2 pages where there are 10 pages. You see 2 pages, you say, yeah, 2 pages, good. But are you sure? You know your file, okay? So that's an interesting thing. If you have millions of files or thousands of files, you need to know each and every file. That's an interesting concept. So that means anybody who is new cannot test this software. That person will have to create their own files. So that's an interesting situation. Do you see the problem here? I opened something. I saw what I saw. How do I know that what I saw was what was to be seen? So when you look at post condition, you ask yourself, how do I know that what has happened is correct? So let's ask. After you double click on a file, for example, what happens? Describe to me, please. What happens when you double click a file, a text file? It's opening in default application. Okay. How do you know it has opened up? So what do you see? The content of the file is floating in the screen just like that, or there's something else?
Well, there are 2 situations. One when I open already known for me file, and another when I open unknown file.
Which is fine, but when it opens up, what do you see on the screen?
Text.
Just that?
And the number of pages.
Just that? You see the application window, right?
Yes.
Within that, you hopefully see the contents of the file that you have opened up, and hopefully everything is there, right? It was your increment letter, it was your promotion letter, you were made the CEO of the company, but unfortunately the file opens up with a blank page. No, not a good thing, right? So hopefully it has everything. Now what do we see on the screen? Application window and the content. Now let's go back to the basics. Application window, what are the properties?
Scroll bars, menus.
An application window exists there, it has a size, it has elements like buttons, scroll bars, and so on. So when it opens up, should it open up in full screen mode? Should it open up at certain size? Should it open up in minimized position? How should it open up? Which portion of the screen should it occupy? while this may sound as a trivial question, but somebody has to take a decision. The developer has taken already a decision. That means the developer has already put in an assumption that this is how it should really open up. Okay? It should open up on the first page or on the last page. What all buttons should be enabled? What all buttons should be disabled? At what zoom level should it open up? If your application has multiple opening modes, which of the modes should be the default one? And nobody really needs to write a requirement for you. If you keep thinking, you can actually go and ask these questions to the developer, and immediately developer would say, oh, I didn't think of this, I didn't think of that. And you have already found a number of bugs that will be now removed even before the product was developed. So do you see what I'm saying? Because if you go to the window and look at the properties, and the properties, and the properties, you will continue to get more test cases and more test cases and more test cases. So this is essentially some of the test cases, right? Where does it open? What are the properties, location, size, state of the GUI elements? How about this cursor location? Where should the cursor be? Top, middle, bottom right? It's an important question. You see, we haven't talked of the content yet. We haven't talked of the viewport yet. What you see on the view, have you ever seen a director making this kind of a gesture? A film director? No? In some of the TV serials or movies, they show you. So here is this guy who is just looking at you. Oh yeah, very photogenic face. This is the frame, right? This is the frame, but world exists outside the frame as well. I'm cutting that out. So what if my text exists here, here, on the top, and on the left? Meaning, I need horizontal and vertical scrolling both. So when you say it's horizontal scrolling, where should my cursor be? So if I left justify my entire document, hang it from the left corner, and you say my cursor is here, or you want to be on the bottommost line, because the next action user might take is press the arrow button so that the scrolling can happen. So rather than scroll through 25 lines, the developer may say the best thing is to have the cursor at the bottom line so people can move easily. Both are valid arguments. So how do you, I'm not saying which one is right, but what I'm saying is to think of this scenario is important. So these are some of the scenarios. So now you can write more test cases and more test cases and more test cases. So millions of test cases by virtue of combinations is not really all that impossible. Correct? But you say you have cheated, you have just done a combination of one small set of tests that you wrote, and then you are multiplying the same set again and again and again, and you give us millions of test cases. We are not satisfied. Our money of coming here, it hasn't really been returned to us properly. This is supposed to be 80 minutes presentation, right? I seem to be done. I hope none of you, when they go out, is going to ask for a refund of your money because I didn't do 40 minutes. Well, actually, how about this one? Sorry? Just 50%? A little more calculation might be required because the person who is running the conference might actually do some percentages and so on, and he might take money out of my payment, which is not such a good thing. So that means I need to earn my money. Let's take a look at the screen once again. How much time do I have? We were supposed to have a break in between. Has that time passed?
No.
It's now. So okay, let's do one thing. We take a break. Once we come back, we are going to do a simple exercise. So you're going to use your pen and paper, try to create some tests based on noun and the properties and the technique that we use. Very simple technique, very easy to use. This question still remains, if I have millions of tests, I'm in no position to write them down, I'm in no position to execute all of them. So what do I do with these millions of tests? So that question still needs to be answered. And if you think that's a great mystery and you would like to know, that's my way of hooking you so that when you go out, I ensure that you come back in. So go ahead, please, enjoy your favorite poison, tea or coffee, tannin or caffeine, whatever you want, and please be back. Thank you. 10 minutes, 15 minutes? How much time do we have? Yeah, okay, so let's come back. Two-directional, bidirectional relationship, meaning if I do something here, it has an impact here. If I do something here, does it have an impact here as well? So I need to analyze those relationships, and on that basis, I can have yet more test cases. So I compare it to a string of a net. You have thrown the net in the sea, and there's just one string that you pull, and you get lots of fishes. So just with 2 words, file and open, we have got lots of test cases which cover lots of functionality. Now, before I give you the exercise, how many of you have heard the word Sanskrit? Do you know what it is? Sanskrit.
Yeah, it's something related to some language that my yoga teacher is using, Sanskrit language.
Yeah, so Sanskrit is the oldest living language in the world. And it is, if it is not mother of all Indo-European languages, it is definitely mother's sister. So there are a lot of Indo-European languages that derive from a language called, we don't know what that language was, but the name we use is Proto-Indo-European. Okay? So German, French, Italian, English, Sanskrit, Greek, they are all related because they flow in the same language family. So when I looked at nouns and verbs, I was reminded of my Sanskrit lessons. And before I get into the Sanskrit lesson, I need to tell you a very interesting experiment that was done by some scientists. Do you agree with this statement that our language defines our thoughts?
No.
Our language influences how we think.
Depends on people. It's not we cannot generalize.
So, this experiment was done, and please look it up. They looked at, they got themselves 4 sets of people. People who spoke only German, people who spoke only English, people who were native German speakers but spoke good English, people who were native English speakers but spoke very good German. And they showed them a picture. There was a car, there were some bags, there was a woman who was trying to get into the car, and they said, describe this, write a sentence for this. So the English speakers, they wrote, a woman is getting into the car. A German speaker wrote, a woman with a lot of bags is trying to get into a car to go somewhere, for example. When they asked a German speaker to write this in English, he wrote, a woman is getting into the car. When they asked an English speaker who also spoke German to write it in German, he described it with the suitcases and so on and so forth. So they concluded, and of course a lot more experiments have been done on this, each language has a structure. Each language looks at the world in a particular way. And that is your worldview that gets defined because of the language. Language has 2 parts. One, the grammar, second, the vocabulary, the words. Some languages have some words. There are no equivalent words in other languages. Other part is grammar, which forces you to think in a particular way. And how does Sanskrit force you to think in a particular way? I'm going to tell you this. It says that if you really want to think about something, if you are writing a sentence, it's not just subject and the object that you need to look at. You need to look at many other things. I am going. I am eating food. What's the subject? What's the object? I. Object is food, right? Here they say, okay, who, right? So this is the subject. Who is the doer of this task? Can you see it at the back? Not very clear? Okay. So let me see. Is it a little better now? For the front people, it may not be. So that's the hard choice that you have to make. The subject, the object, but then how is the subject doing the action on the object? What is the agent? What is the thing that is being used to do this action? What are the means by which this thing is being done? Okay, this is being done, but for whom it is being done or to whom it is being done. So now you're not only thinking of two immediate things, the subject and the object, but you're also looking into more details of how this is being done, using what it is being done, for whom or on whom this is being done, what is the raw material that is being used, what is the source, what is the motive, who does it belong to, the place or the situation of the thing. Now, you're not looking at just one sentence, you're looking at it holistically. When you're writing it in a sentence, you're looking at everything associated with it. We just looked at the nouns, verbs, adjectives, and adverbs. What if we started writing tests asking these questions as well? Not just these two, but these questions as well. So you don't need to really learn Sanskrit grammar. If you just go through the English part of it, you will get much better understanding of the requirement. I'm not even asking you to write the test cases. All I'm saying is you read a requirement, you really want to analyze it, just put this on a checklist. All these things put on a checklist, every sentence ask these questions. Or every meaningful sentence where you think these things make sense, ask these questions, and suddenly you have a lot of unanswered questions. Those are the bugs that you've already found, even without any coding or testing. So this is basically the linguistic analysis in greater detail of how you can use, because requirement is nothing but expression of a desire in a particular language. So if you can analyze the language, you can analyze the desire in a much better way. So this is essentially the technique. You can apply it anywhere where you want. If you know the domain, it becomes easy to find the nouns. If you don't know the domain, for example, I say test AI. Now you'll ask, what are the properties of AI? Sorry, I know nothing about AI. In which case, you can't really do the decomposition. So you need people who have some knowledge of the domain, and then you will be able to do this better. Okay. Having done that, so you can actually take a look at this slide, which talks about what are various speech patterns here that you can look at. Now I'm going to give you an exercise. Okay? 10 minutes. I'll just throw some interesting questions to you after we do this exercise. How many of you have used Control F on Microsoft Word? We have to test Microsoft Find feature. Is that okay? Microsoft Word Find. So I'm restricting the problem for you. I'm just saying there is this dialog which has a text box in which you write your search string, and it searches in a given document. That's my requirement explanation to you. And you have to write test cases based on this. So what is your verb and what is your noun? Noun is find a string, right? So find is the verb, the string is the noun. You have to write tests. If you want to draw diagrams to help you understand what are various nouns, what are various elements, feel free to do that. You have 10 minutes, you can talk to each other, you can figure it out. One thing that I've found that really helps is talking to yourself. Yeah, talking to yourself really helps. No, I'm not saying it helps in going to a asylum. It helps in clarifying things. So, you can speak to yourself. How does this find happen? What do you do? What do you press? What do you write? Where does it find? What does it find? And so on. And you will find that things become clear. If you have any questions, feel free to ask. It need not be an individual exercise. Just to remind myself, I have to tell you how to reduce the number of tests from millions to a manageable number. So once you're done, we'll talk about that. Go ahead, please.
What's the budget?
What's the budget? In writing the tests, you have enough budget in terms of, in thinking of the test ideas, because they should not take more than 2 hours. To test, how much time and so on, that depends.
I'll write as many tests as of the budget. When I exceed the budget,
Before you do that, you need to prioritize your tests. That means you should have the whole test problem space in front of you, and then within the budget, you should be able to pick up the best tests to do within that budget. Most risky ones, right? So that's why the first step is still identifying those millions of test ideas. So once you think you are done, you can't do any more, let's start a quick discussion. Shall we start a discussion? Okay, what's the problem? What's the problem statement? Find a string where? In a given file. Okay. File we don't even need to talk about. There are dozens and dozens of different types of files that we have talked about. We didn't talk about the content of the file, text, images, right? Image only, text plus image, vector graphics, whatever you have. So this is okay. Now tell me, what is the noun that you're looking at? String, okay? So string is the noun that you're looking at. What are the properties of string other than what we wrote down here? Right now we are just looking at the string. We are not looking at the verb part yet. We'll come to that. The string, you have to qualify it. Which string are we talking about? The string which is the search string, correct? The string that we are trying to find out.
Links.
Yeah. So, okay, so the string that you're trying to find, and you have a number of possibilities there that we found out, the length of the string, the type of characters that there are, right? And anything else? Starting with? Okay. Sorry? So let me simplify the problem. The search doesn't allow any regular expressions, any wildcards.
You need to try.
Yeah, agreed. You need to try and you need to see what happens. But I'm just kind of, trying to make the problem simple so that we can, look at the problem. So you said, sorry? Capitalization, yeah. So, excuse me, we did not discuss capitalization when we looked at strings. Now that's actually an interesting point, because Windows versus Linux, they behave in a very different way with respect to capitalization, file names, correct? Similarly, inside the file as well. What else? Sorry? Exact match. We'll come to match. Just give me 2 minutes, we'll come to match.
Match.
Not yet. I don't really need to waste paper. I can write here. And yes, this is whiteboard marker. Okay. Let's try to do it visually. Okay, and cancel. And you write something here, correct? Just writing it or drawing it gives me a lot of ideas, which I'll discuss later. You have a string here. You say, what are the properties of the string? And then everything that you said, including capitalization, length, characters, type of characters, and so on, correct? Is there some special meaning of certain characters? Certain sequences which are allowed or not allowed? So for example, if I try to find a word versus I try to find a sentence, if there's a space in between, will it actually look at finding all of these different as words, or will it take it as under double quotes and try to find an exact match for that, and so on? Those are the kind of things that we need to look at. So type of characters, that's where all things would come. Okay, now what happens? Let's look at the whole process. You press OK, and let's say something is found. What happens? How does that happen? So there is your Word document, for example. It has some text. So where it is find would be highlighted. So let me use the word highlighted. Right? Now you see there's a string here and there is a string here. Yeah, you have a question there at the back? No? Okay. Do you see these are also strings? So you're trying to find a string inside a string. Now these are two nouns. One noun actually string, but two different types of strings. They have a relationship. What could be the relationship? So when you use the word exact match, my idea was exact match is an idea that has come to your head. Can we do it in a process or in a technique manner? So I'm looking at this as a string, this is a string, and a relationship between these two strings, which could be one is contained in another, one is not there at all, one is there partially, and so on, right? Or one is repeated. So you can think of all these combinations and you will start getting test cases. Now I would just say I apply the technique and I find some really interesting cases here, not going into other details, but looking only into the interesting part of it. Highlight. What is highlighted? The the string. But the string is being represented visually, right? And we saw that when you represent a string visually, it has a font. It needs a font. What kind of font is it? Does the font, so if there are multiple types of fonts, is my search dependent on the font type or independent of the font type? It's a good question. Do you think it's dependent or independent?
Depending.
English, it's really
That's okay, but
It has to be right because if your document has styles that is used for highlighting, then highlighting have to change its style from
Right.
default to another one.
so one is font, multiple types of fonts. You have to test with those. Other part is the highlight. Now let's look at the properties of the font. A font has a size, font has color, correct? Font has type, and so on. Color. So we look at color, highlight. What are the properties of a highlight? It has a shape, size, color, color and color. If font is black, highlight is black, how does it work? Oh, the font has to invert its color. If it is black, it has to become white. But what if the font is not black but blue? Oh, it still converts to white. That's what we know, right? But that's a question. First time when you're implementing it, that's a question that has to be asked. Okay? And then what happens when the highlight is removed? Those questions come automatically later. Size of the highlight. Font also has a size. What is the relation between these two? Does one word necessarily have only one font? Each letter of the word can be in a different font, different size. Then how does the highlight really fit? So those are questions to be asked, tests to be done. Believe me, these are important tests for somebody who creates a software like Photoshop, who creates a software like Acrobat, maybe even Word, PowerPoint. So these are not trivial test cases. These are important test cases because your experience of the product is going to be defined by those. Now let's look at one more thing. The highlight, it has a position, right? String also has a position. Can we have position test cases? You had a test case, the string occurs number of times, right? Somebody had mentioned that whatever I'm trying to search occurs 0 time, 1 time, many times, okay? This is my visual representation. Where does the many times occur? Oh, here and here and here and here. Fine. The string to be found is here, but this is not in the viewing area. Now how should the software behave? Somebody has to code that, right? The document should move up. To what level? This highlight should come here or in the center when the document is moving up or at the top. Now that's a decision a developer has to take. Nobody is going to write that detailed requirement, but these test cases become interesting test cases. And now this also has a position. This has a position. Can you do a position test case? The dialogue, whatever I am searching for is just behind the dialogue. Now should the dialogue move up or down, or should the document scroll up or down? Mind you, it's a different test case. In this case, it was not visible. It was not in the viewing area, and hence it was not visible. It is in the viewing area, right, but still not visible. The developer may or may not take care of such a situation. So when you connect nouns in this way and start looking at these interesting possibilities, a lot of interesting test cases begin to happen. I can also say, now look at this has a length, this has a length. I'm trying to search a string, which is the entire paragraph. Does it highlight the entire paragraph? Oh, this is just trying to search 10 letters. 3 letters are here and 2 are here. How will the highlight work? Will it only be like this, or will it be like this? And so on. So the more you think of these properties and try to connect properties of these different nouns, the more interesting scenarios you can come up with. So it's a way to think about the product, get deeper into it and deeper, and you can get a huge number of tests. And that's the problem of the technique. You have so many tests, what to do? Well, don't write them, first of all. Just identify the base elements, put them on a piece of paper or on a wall, and just look at them. Use your eyes to connect them, to iterate over them, and you will find interesting tests. Note down the interesting tests. Whatever is not interesting, you don't need to note down. So essentially, you see the whole universe of the possible combination that can be there. Whatever can easily jump out at you while just looking at them, combining them in your mind with your eyes, just use those. Someday, hopefully, AI will iterate through all these millions, billions of combinations and will give you the most interesting ones. Till then, we have to make do with natural intelligence. Yep. So that's all I had to say. You have any questions, feel free to ask. Will it work in Agile? Somebody can ask me this question. When I have only 2 weeks of delivery window, yes, we have used it. In Agile, it works really well because you need to think of interesting ideas very quickly. Mind you, we are not writing the test cases, as our friend here said. And how do you pronounce your name? Jore. As Jore said during the break, he said, these are not test cases, these are test ideas. Okay, I'll use the word test ideas. If you can think of test ideas, that's all that I want you to be able to do. So in Agile, you need to think of test ideas, possibly not write them. And so just think, note down one word test case or test idea, maybe one phrase, maybe one sentence, but not more than that. And that should be good enough. Will it work for AI? Anybody tests artificial intelligence software here? AI cannot be tested automatically. AI cannot be, as of yet, tested using AI. You need human beings, and you need human beings who have the capability of think of various, what mostly developers call as corner cases. Have you ever heard the word corner case? Yeah? Right. So, testers typically did not use these words, but with developers being more prominent in testing with Agile and DevOps, corner and edge cases have become very popular word in testing terminology. You need testers who have the capability to think of edge cases. This is a technique that can help deliver those edge cases to you. No other technique that exists will be able to deliver such edge cases. And AI is all about edge cases, because when you have gigabytes of data going into it, you just can't test everything. So you need some mechanism to do that. Just to give you one example, are you aware of AI-based systems and how they work? For example, images. What happens with images? When you see, for example, this, what do you see? A marker? That an AI will see. If you know what's a marker, you'll immediately see marker. This thought that you had, red and white, was an afterthought, not the first thought. But AI will see a set of pixels. It will run an algorithm which will then say, yeah, something cylindrical almost with red and white. Okay, but what is it? Looks like a pen, specifically a marker. But then if there is something here, which is a lion, will it see that lion as a lion or just as a logo or a symbol? Because as far as image is concerned, a picture of a lion on a pen is equivalent to a picture of a lion in the jungle. Lion is a lion, right? How will AI distinguish that this is a picture of a lion on the pen and hence not a real lion? So if I put this in this room, the AI should not actually throw out a warning to all, oh, there's a lion in the room, run. Oh, it's just a logo. right? Whereas if there's really a lion in the room, the AI might want to shout that out. So this is a problem with AI. And one interesting thing that some people did was they added, for example, this is called as adversarial attack. They added some pixels to 3 different pictures. One picture was a teddy bear, other was a dog, other was something else. And they added some random pixels that you could not see. A human eye could not see any of those. So the picture looked the same. And when they fed it to an AI, image classification software, in all 3 cases it said this is an ostrich. Just some random pixels, not really random, carefully crafted, but that AI thought it's an ostrich. Some people took their horn-rimmed glasses, printed some things on those, and now when they went to this AI, so there's a security system, there's a camera there, it's looking at you, and if you're not allowed here, it's going to shoot. So who does it allow? So not a layperson like you and me, it allows Ethan Hunt. You know Ethan Hunt? Mission Impossible. What's the name of the actor? Tom Cruise. And this person has this glass, is not Tom Cruise. The AI looks at this, looks at the pattern on the glass, says Tom Cruise. Now that's the easiest way to get fame, right? How do you test these kind of things? With your regular test design techniques, you cannot use them. Think of, a driverless car. It doesn't see a human being. It sees just pixels. Then it has to find out that's actually a human being. It's a cycle. Cycle is not visible. It's fully covered with grass. Only one small part of the tire is visible. A driverless car still has to understand it's not a bundle of grass, it's a cycle. So
Even if it is a grass, it should be an obstacle on the road.
it may not be. If it's just a bundle of hay which is going with the wind, it's not an obstacle. I'm going at 120 miles an hour. I don't want to stop just for a bundle of hay which is going in the air. Do you see what I'm saying?
Are you sure?
Yeah. Not, a bundle of, it's not a hurricane, so we're not talking about that. But what I'm saying is there are many situations for which you need these edge cases. This is a technique that can help you think of edge test cases. So with that, I end my lecture. If you have any more questions, feel free to ask. Otherwise, thank you so much. So I have this to be given away. Questions were asked. He asked the most. There you are. Thank you so much, friends. Until next time.
It's not the same one.
Thank you.